The length of a rectangle is 5 feet less than twice the width. The area is 121 square feet. Find the length and width. Okay, so you might see some questions like this come up in class, and they're some of the most confusing questions that students come across. They're worded in such a convoluted and seemingly unnecessarily complicated way. Again, the length of a rectangle is 5 feet less than twice the width. The only way to really untangle these is to really take your time and try to write out in a simplified form what the question is trying to say. And this just comes with experience and practice. So let's look at this one. The length of a rectangle is 5 feet less than twice the width. Okay, so the length of a rectangle is, so when you see is, that means equals, right? So the length of a rectangle is equal to 5 feet less than twice the width. So two of the widths, it's 5 feet less than this, so minus 5. So the length is equal to 5 less than, so minus 5 off of twice the width, so 2w. So that first sentence is giving us this equation here. Call that equation 1. Usually there's one complicated equation to try to figure out and one that's relatively straightforward. So the other equation that you get here is going to have to do with the area, because we're told the area is 121 square feet. So the area is 121, and area is just equal to length times width. So length times width. That one's a lot more straightforward, at least I think, to figure out than this one. So once you have these two equations, we have two equations and two unknowns. That means we can solve for everything. If you have the same amount of equations as you do unknowns or variables, that means you can solve for everything. So let's go ahead and solve these, and we can use substitution if we want. So we could sub equation 1 into equation 2, right? Sub 1 into 2, and the reason I say that is because equation 1 we've already isolated for L. So wherever you see L here, just swap it out with this definition. So 121 is equal to L, but instead of L we write 2w minus 5 times w. Okay, let's solve for w. How do we do this? Well, 121 is equal to, distribute this w in, 2w squared minus 5w. Okay, bring the 121 over here. So 0 equals 2w squared minus 5w minus 121. What do we have here? We have a trinomial, right? So to solve for w here, we could use decomposition, although I'll tell you right now I don't think this one will be too promising. Or you could use the quadratic formula, or even complete the square and solve for w. So if you want to use the quadratic formula, go ahead and just plug these numbers in, a, b, and c, or we can complete the square, and we can do that pretty quickly actually. So let's go ahead and we can try that. You'd have 0 equals 2w squared minus 5 over 2w minus 121. I'm going to add and subtract my special number here, which will be 5 over 2 divided by 2, which is negative 5 over 4. Square it, and you get plus 25 over 16 minus 25 over 16, just like that. You can take that one out. So I'll have 0 equals 2. And then with these three I can factor w minus 5 over 4 squared minus 121 minus 25 over 16, but I'm going to multiply by 2, so it becomes minus 25 over 8, just like that. I can combine those two terms together, right? Just need a common denominator. So I'll have 0 equals 2 w minus 5 over 4 squared. Negative 121 you can turn into negative 968 over 8 minus 25 over 8. And those two will combine to be negative 993 over 8, right? And what you're going to do in the next step is just move it to the other side, because at this point we've successfully come up with our vertex form. Now we just have to solve for w. So move that 993 over 8 to the other side, 993 over 8. But I'm going to divide both sides by 2 to get rid of this 2, so that's actually going to become 16. So I can do that in this step here. So that's w minus 5 over 4 squared. Then you square root both sides, right? So when you square root this, you're going to get the square root of 993. You can actually square root the bottom to get 4, right? And it's plus or minus, of course. And that's equal to w minus 5 over 4. Bring the 5 over 4 to the other side, so you get 5 over 4 plus or minus this over 4. So really you're getting 5 plus or minus square root 993 all over 4 equals W, right? Because they have the same denominator. And so W, you're going to get two answers, right? You're going to get, if you calculate this, approximately 9.13 feet. And you also get negative 6.63 feet, right? Because plus or minus, you're going to get two answers. Now, because this represents a real dimension, it represents your width, this negative answer here is just theoretical. It's not real. So W equals 9.13 feet. That's the answer you're going to go with. And again, you could have tried to do this by factoring. It might not have worked, but you could have used the quadratic formula instead. You don't have to complete the square in order to solve for the variable, but it's an option. Now, so that was the width. We also have to find the length. We already have an equation for length, right? Length is equal to 2W minus 5. Plug in that W. Length is equal to 2, 9.13 minus 5. Therefore, length is equal to approximately 13.26 feet. Now you have your width and you have your length, and that's it. Okay, let's go on to another question. For this question, it says the length of the shortest side of a right-angled triangle is 4 centimeters less than the length of the hypotenuse. The length of the remaining side is 2 centimeters less than the hypotenuse. Find the lengths of all sides. So another question where they're telling you that certain things are less than other things by certain amounts, and you got to somehow come up with the equations for these, right? Let's try to visualize what we're talking about here. You have a right-angled triangle, right? You have your hypotenuse here, which we'll call C, right? And you can call this A and this B, just like we normally do. And one equation that we know when it comes to right-angled triangles, when we're trying to relate the sides to each other, is the Pythagorean theorem, right? A squared plus B squared is C squared. So automatically, that's one equation that you have, right? Call that equation 1. But they're also giving us some more information here, right? Like we know that B, right, the longer side, is 2 centimeters less than the hypotenuse, so C minus 2. And A, the shortest side, is 4 centimeters less than the hypotenuse, so C minus 4. So with all that in mind, we have now these equations as well, right? So you call that equation 1, you can call this equation 2, and you can call this equation 3, right? So now we have 3 equations and 3 unknowns, right? A, B, and C. We have 3 unknowns. So like I said before, you need the same number of equations as you do unknowns in order to solve for everything. So it looks like we're going to be good here, right? We got 3 equations, 3 unknowns, we should be good. So what can we do? Well, I can plug equation 2 and 3 into equation 1, right? Because A squared, I can replace A with C minus 4. So C minus 4 squared plus, well, B squared, I know B. B is C minus 2. So I'm going to put C minus 2 squared. And that's equal to C squared. What we have now is an equation with just C's, so we can solve for C, right? And the way you're going to want to do that is by expanding these brackets and collecting like terms. So C minus 4 squared, that's going to end up being, if you want to show C minus 4 times C minus 4 and then FOIL, you can do that. Or if you're familiar with how to multiply out binomials that are squared, you can just do the following. You can say C squared minus 8C plus 16. That's what this first one's going to become, right? Because C times C is C squared. C times negative 4 is negative 4C, and then you do negative 4 times C, you get another negative 4C, that becomes negative 8C. Negative 4 times negative 4 is 16. So you can think about that, or you can write it out, do your FOIL. And then we're going to do this one. You're going to get plus C squared minus 4C plus 4, and that's equal to C squared. Now let's try to collect like terms. You have a C squared on the right and a C squared on the left. So if you want, those two can just cancel out. Instead of bringing them to the same side and showing C squared minus C squared is 0, they cancel. Just cancel them out right now. You do still have a C squared over here, that's okay. Look at your C values. You have negative 8C, negative 4C, that's going to become negative 12C. And you have 16 plus 4, that's going to be plus 20. And it's all equal to 0 now. So now you have a trinomial, and you can solve for C, right? You just got to factor it, right? If factoring didn't work, you could use completing the square, solve for C, or you could use the quadratic formula, but I think we're going to be able to factor this one. It's a simple trinomial, so we just say what two numbers multiply to 20 and add to 12. or negative 12, right? So multiply 20, add to negative 12. I think it's minus 10 and minus 2, right? Negative 10 times negative 2 multiplies to negative 20. Negative 10 plus minus 2 is negative 12. So that's going to work out nicely. So that means that C is equal to 10, and C is also equal to 2. Those are the two possible values we have for C. Now, one of these is real, one of these is not the real answer. And the reason I say that is because you're typically going to get two different answers, but one of them is just theoretical. If you look at this triangle, if C was 2, well, B couldn't be C minus 2 because then B would be 0. And A couldn't be C minus 4 because then A would be negative 2, and you can't have a length of negative 2 or 0. So this must just be a theoretical answer. The real answer must be C equals 10 centimeters. So when you get these answers, you always got to think critically about them and figure out, okay, which one is the realistic answer, and then pick that. So C is 10 centimeters, and based on these other equations, 2 and 3, we can find A and B. Right? A is equal to C minus 4, so 10 minus 4. Therefore, A is equal to 6 centimeters. B is equal to C minus 2, so in other words, 10 minus 2, so B is equal to 8 centimeters. And now we're done, right? We've solved for A, B, and C. Okay, let's do another question. A rectangular pool is 3 meters by 4 meters. It is surrounded by a deck of uniform width. The total surface area of the pool and deck together is 172 square meters. Find the width of the deck. So for these types of questions, I like to do a diagram, right? Or a little bird's eye view sketch. So here's the pool. It's a rectangular pool. It's kind of funny, but that's okay. And they say it's 3 meters by 4 meters. So I'm going to say this is 3 and this is 4. They also tell us that there is a deck of uniform width. What does that mean, uniform width? It means that it's the same width all the way around. So imagine a deck surrounding the pool, something like this. And the uniform width means that this width here is the same as this width over here, and it's the same as that width there and this width here. Those are all the same lengths. That's what it means. Now they also tell us that the area of the whole thing together, the area of this big rectangle, is 172 square meters. So we have to come up with some equations, right? First thing I'll say is, what's the length of the whole rectangle? Well, I know the length of this little rectangle is 4, and then I know there's a width here and a width here. So if you want to say what this whole length was, you could say it's 4 plus W, or 4 plus 2W. That's the length of the whole thing. And then the width of the whole thing, you can probably guess what this is going to be, right? It's 3 plus this width plus this width, right? So you get 3 plus 2W. That's the width of the whole thing. So if you're going to write an equation to represent the area of the whole thing, the 172 square meters, you could write 172 is equal to the length, 4 plus 2W, times the width, 3 plus 2W. Now you have an equation here where W is your only variable, so you can solve for it, right? You just got to expand and collect like terms. So 172 is equal to 4 times 3 is 12, 4 times 2W is 8W, 2W times 3 is 6W, 2W times 2W is 4W squared. Move this 172 to the other side. We can collect all of our like terms. So you'll have 4W squared, 8W plus 6W, that's going to become 14W. And you'll have 12 minus 172, that's going to become minus 160. Okay, you can common factor out of 2, and you'll be left with 2W squared plus 7W minus 80, like that. Okay, now we have to find what is W equal to. We can try to factor the inside using decomposition. That might not be too promising, right? It's not guaranteed that that's going to work, and it looks like it's going to be a bit of trouble to figure out. So you could complete the square like we did earlier and then solve for W, or you could use the quadratic formula. We already did an example where we complete the square, so let's use the quadratic formula for this one. So the quadratic formula says that x, or in this case W, is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. Well, this is your a is 2, your b is 7, and your c is negative 80. So W is equal to -7 plus or minus the square root 7 squared minus 4 times A, which is 2, times C, which is -80, all over 2 times A, which is 2 times 2. Okay, so W equals, what do we have? -7 plus or minus the square root. 7 squared is 49. -4 times 2 is -8. -8 times -80 should be positive 640. So 640 plus 49, that's going to be 689. And this is all over 4. So now we can calculate what our two answers would be, right? So we do -7 plus root 689 divided by 4, and we do -7 minus root 689 divided by 4. We do both those calculations, and one answer you get is going to be approximately 4.8 meters. And the other answer you get is going to be -8.3 meters. Now obviously your width can't be negative, so just like the other questions we did, that's not a real answer. This is our answer. So the width of the deck is going to be approximately 4.8 meters. And you can check your work, you can plug this into the earlier equations, right, and make sure that it all makes sense, right? Up to you.